Okay, this is our 2.2, which is lesson 2.2, which is on kind of a review of factoring. I want this to be a video lesson simply because you've seen all this stuff before. You should be masters of the universe on this. I don't want to spend valuable class time going over stuff that you should already know. So here's video lesson. The homework is to definitely complete the questions that we don't do on video. The video is really here for your purposes to review. And here we go. So our first factoring tool that we should have learned way back in 8th grade is factoring by using a greatest common factor, or by finding a greatest common factor, or a GCF. And basically what the concept is kind of you're undistributing. So you're looking at what the terms have in common and you're figuring out, well, what's the most I can take out of those terms to undistribute. So let's just do an example. So if I look at, I have 2x, if I look at A here, 2x squared y minus 6xy squared. Well, first I'm going to look at the numbers. 2 and 6. The greatest common factor of 2 and 6 is 2. So I can undistribute a 2 from this already distributed out expression. Then I have my x's. I have x squared, I have 2 x's here and 1 x here. So I can take away from them 1 x. They each have an x to give me. They don't each have an x squared to give me because the term 6xy squared doesn't have the x to give me. And now I'll look at my y's. So my y's, the first term has only 1 y, the second term has 2. I'm trying to take what I can away from both of them. I can only take 1 y away from both. And now I write parentheses to figure out what's left inside the parentheses. Because remember, I'm undistributing the 2xy. So there's a few ways you can do that. You can do it mentally. You could say, okay, 2xy times what will give you 2x squared y? And the answer is an x. 2x squared y times x gives you 2x squared y back. Then I'm going to decide, I'm subtracting here, 2xy times what gives you 6xy squared? Well, 2 times 3 gives you 6. X times 1 gives you x, so I don't need to put an x inside the parentheses. And y times y gives you y squared. That's one way to do it. Another way to do it is to recognize that multiplication and division are opposites. So when I'm trying to figure out what I'm multiplying 2xy by to get 2x squared y, I can think of that as really doing a division problem. So I can think of saying, I'm going to take 2x squared y and divide by 2xy. And 2x squared y divided by 2xy, well, the 2's divide out, the y's divide out, and x squared divided by x is x. So that works. Same thing with 6xy squared. I can divide it by 2xy. 6 divided by 2 is 3. X divided by x is 1. Y squared divided by y is y. And I'm left with 3y. All right, just quickly, let's do another one. I have 9x squared minus 27x. I'm looking for my GCF. The GCF of 9 and 27 is 9. And then the GCF of x squared and x is just x. So my GCF is 9x. I'll just do the division method. It's a little easier in some sense. 9x squared divided by 9x is x. 27x divided by 9x is 3. So that would be these would be my factored form. Remember, the word factor means things that multiply to something else. So that's what's happening here. All right, number 2. We have the difference of 2 squares, which some people have come to abbreviate as dots. Difference meaning a subtraction problem. 2 perfect squares. I have to have 2 things that, when I think about them, can I multiply something by itself to get there? So for example, x squared minus 25. X times x gives you x squared. 5 times 5 gives you 25. And the way to make this work is you alternate the signs. I'm actually going to put the minus first. You don't need to, but there's a good reason why, and you'll see later in this video. And there's my factorization. 16x squared minus 25y squared. So I'm looking, by the way, you should always check to see if there's a GCF first. And we're going to see that a little later on. 16 and 25 do not share a factor. So this is straight up dots here. 16 comes from 4. That goes in one place there. 25 comes from a 5, 5 and 5. X squared comes from an x. And y squared comes from a y. Whoops, I didn't give myself enough room over here. So this is 5y, 5y, minus, plus, you're done. By the way, if you wanted to check this, you could multiply this out. So this would be a check. So 4x minus 5y times 4x plus 5y. We're unmultiplying, so we can multiply out the check. 4x times 4x is 16x squared. Now watch what happens here. 4x times 5y is 20xy. Negative 5y times 4x is minus 20xy. So that's the beauty of this factorization. Those middle terms go away. They're opposites. And then negative 5y times positive 5y is positive 25y squared. And then you're back to the 16x squared plus 25y squared. This is the answer, by the way. This is just a check. All right, next up, we have trinomial factoring, which by many teachers in our department has been called or dubbed IM factoring. That's not a term you would see in a textbook, but it is kind of useful to remember how to do this. So I have x squared minus 6x plus 8. The name of the game here, first of all, I hope we see this as a trinomial. There are 3 terms. There is no GCF. The name of the game here is to figure out what adds up. Well, first of all, the I stands for 1. That means that coefficient in front of the x squared needs to be a 1. The A stands for we're looking for 2 numbers that add up to negative 6 and multiply to 8. Okay? Looking for 2 numbers that add up to negative 6 and multiply to 8. So it's much easier to start with factors of 8. And those factors have to add up to negative 6. So just a little thinking here. If the numbers multiply to a positive, that means they have to have the same sign, either positive sign or negative sign. If they're adding up to negative 6, the only way to make that happen is that my numbers have to both be negative. Now I'm thinking, what 2 numbers multiply to 8 and add up to negative 6? Well, that pair would be negative 4 and negative 2. And I hope you guys have fluency with this, meaning you could just see negative 4 and negative 2 without doing any thinking. And then my factors are going to become, I have x times x gives me x squared, minus 4 minus 2 here. So my factors are x minus 4 times x minus 2. And again, this is the answer. You can always check this. We can check by multiplying it out. X times x is x squared. X times negative 2 is negative 2x. X times negative 4 is negative 4x. Negative 4 times negative 2 is positive 8. These 2 terms add up to the negative 6x. These 2, the n guys multiply to positive 8, and that's really why it works. Okay? So this checked out. That looks like an 81, and I didn't need to write that. Here's plus 8. It checks. Similarly, we have x squared minus 8x plus 16. So, again, we're looking for 2 numbers that add up to negative 8 multiplied to positive 16. Those numbers are going to be minus 4 and minus 4. And we can even write this as x minus 4 squared if you wanted to. Either way is acceptable. Either answer is good. Okay, number 4, factoring completely. Okay, now, in 8th grade, you may have been told, hey, factor completely. In 10th grade, no one's going to tell you that necessarily. You're going to have to see it for yourself. When you factor something completely, what you're doing is you're combining 2 or more factoring techniques in the same problem. So for example, in G, what I should really always look for, the king of factoring is GCF. I always want to look for a GCF first. So if I look and I have negative 2x cubed plus 18x, I see that I have certainly an x that they both can get out, and I can also take out a 2. Okay? Now here's what I'm going to do. I'm actually going to take out a negative 2, just to show you what you can do with this. I'm actually going to take out a negative 2, and that's going to leave my leading coefficient with a positive number, which is generally desirable, and you'll see in H why it's desirable. So I'm actually going to take out a negative 2x, so that my leading coefficient, my x cubed term, my highest degree term, ends up with a positive sign. So if I do this, I have negative 2x cubed divided by negative 2x, and I'm dividing the other guy by negative 2x. I will have x squared. The negative 2's will divide out. Now 18x divided by negative 2x becomes negative 9. And now I hope that you see, because we took out this negative sign here, it's very easy for us to identify this inner piece, this x squared minus 9, as dots. This is a dots factoring problem. In fact, that's our next factoring that you look for. You look inside the parentheses and you look and say, oh, that's a dots problem. And that red problem now factors into x plus 3 times x minus 3. And on the outside, we still have that negative 2x. It needs to come down because I'm factoring the original problem. Negative 2x is a factor of the original problem. Done. Okay. I'm going to leave my checklist intact on the side here. So I have h. H says negative x squared plus 8x plus 20. I want to factor that. Now, it may not appear that it has a GCF, but in some sense it does. Because first of all, remember, it looks like an IM problem, except there's one issue. This guy in front of the x squared is not a 1. It's a negative 1. So I'm going to actually rewrite it like that. And I'm going to say to myself, well, if I could get rid of this negative 1, then it would become an IM problem because the coefficient of the x squared term would be a positive 1. So that's exactly what I'm going to do. I'm going to apply a GCF concept to this. And I'm going to factor out a negative 1. While that might not seem to be like a GCF, it really is in some sense. Now, if we do this, watch how nice this becomes. We get negative 1x squared divided by negative 1, which is regular 1x squared. Looks like we're going to get a candidate for IM now. Positive 8x divided by negative 1 is negative 8x. And positive 20 divided by negative 1 is negative 20. And now look inside. The red stuff, or actually I'll do it in blue, this blue stuff is now an IM problem, which is one of the things you have to check when you factor something completely. So now we have negative 1, and now I'm going to fat times this blue stuff. That's an IM problem because the coefficient of the x squared term is a 1. There's really an imaginary 1 here. So I'm going to have x times x, and now I have to think of two numbers that add up to negative 8 and multiply to negative 20. And you guys should be totally fluent with this. The answer is negative 10 times positive 2 gives you negative 20, and negative 10 plus 2 gives you negative 8. If you can't do this fluently, come see me. I have a calculator trick that I'll show you. But I don't want to give out calculator tricks unless people really have a hard time with the concepts, with the numbers. I'd rather you try it on your own first. So now I have my factors, x minus 10, x plus 2, done. That's it. There are a couple others I wanted to walk you through, just because they're a little more complicated. Let's see. Number 10. So number 10 says we're going to factor 4x to the 8th minus 64. So firstly, I hope that we see that there's a GCF of 4 and 64. And that GCF, because again, I'm thinking of my checklist. My checklist GCF, I should have written this at the beginning. Dots and IM. I have a GCF of 4, and I hope we see that. So that 4 can come out, divide each of these by 4, and I get x to the 8th minus 16. Check. Now, I look and see, oh, inside the parentheses here, I have a dots problem. So now we have to think about this for a second. So I bring down my 4 when I have my two parentheses, and I have, this is the tricky part, x to the 8th comes from x to the 4th times x to the 4th. Again, let's just think about that for a second. We've talked about this at the beginning of the year. X to the 4th is x times x times x times x. Another x to the 4th is x times x times x times x. Multiply them together and I get x to the 8th. Okay? So the exponent goes down, gets kind of divided by 2 here. My 16 becomes 4 because 4 times 4 equals 16. So these 4s are 4s for completely different reasons. That's why this is a good problem to illustrate it. So this 16 becomes 4 and 4, minus and plus. Now, if I look again at my blue stuff, this guy is also the difference of two squares. This guy is the sum of two squares, which is not factorable. That's not factorable. But the difference of two squares is again factorable. So I'm bringing down my 4. I'm also going to bring down my x to the 4th plus 4. And now I'm going to factor this guy. Let me switch my squiggly lines here. I'm going to factor, whoops, never mind, hold on. Boop. switch my squiggly lines here, okay? So I can write this in red. I'm going to factor the red part here. And this guy is also the difference of two squares. X to the fourth comes from x squared times x squared. A 4 comes from minus 2, or 2 times 2. And I'm going to alternate the signs. And now I have to look again and see if I have anything else to do. So by the way, there are actually 2 dots problems here. And everything else is good to go. I mean, I don't have anything else. This x squared minus 2, 2 is not a perfect square. So I'm done factoring. One more I want to go over with you. So we have 3 times a plus 2 cubed minus 6 times a plus 2 squared. Now, this is kind of interesting. So clearly, we're looking for a GCF. And we have a GCF of 3, which I hope is very clear. What might not be so clear is the fact that we have another GCF. So imagine I whited out the a plus 2. Okay? And instead of a plus 2, I had an x here. I had 3x cubed minus 6x squared. Well, then I would take out an x squared. I hope we all see that. Instead of having the a plus 2 in parentheses, I have an x. I would take out an x squared. Well, I didn't have an x. Okay? What we had was a plus 2 and a plus 2. So instead of taking out an x squared, I'm going to take out 2 of the a plus 2 squareds. This kind of freaks people out at the beginning because they don't see a plus 2 as something able to take out. But this term has 3 of them, and this term has 2 of them. And then we have to figure out what's left. So if I take 3 times a plus 2 cubed and divide it by 3 times a plus 2 squared, the 3's go away, and 2 of the a plus 2's go away. So I'm really left with a plus 2 from this division. Minus, let's see, 6a times a plus 2 squared divided by 3 times a plus 2 squared. The 6 divided by 3 is 2. And a plus 2 squared divided by itself is 1. So in reality here, I get 3 times a plus 2 squared times, well, a plus 2 minus 2 is just a. And most people would write this as 3a times a plus 2 squared. People like to put the monomial terms or factors rather in front and the binomial factors in the back. All right, that's it. So work on these problems for homework and clean up your other homeworks tonight.